Okay, so today we are talking about circles. And you may wonder, hey, we've already studied circles. And the answer is, of course, we have. And we are going to be using today to do a little bit of review and just to remind ourselves about circles and then add on just a smidge. So, first thing is, do you remember that we used to graph circles? And so to graph a circle, we're going to start with this equation right here and be like, okay, can I graph this? And I asked students today to say, can you come up with some ordered pairs, excuse me, that make that true? And so, as kids thought about it, like, well, yeah, maybe. And so they say maybe 5, 0, right? 5, 0. Well, if x is 5 and y is 0, you can take 5 squared plus 0 squared. That makes 25. I'm like, ooh, that was kind of cool. What about 0, 5? Well, yeah, 0 squared for x plus 5 squared for y also makes 25. And then some people said, what about 3, 4? What if you do 3 squared plus 4 squared? What's 9 plus 16? Does that equal 25? Well, yeah, it does. And so 3, 4 is another option, as is negative 5, 0 and 0, negative 5. Every point on this graph is going to be 5 steps away from the origin, its center. And you can even do that with the Pythagorean theorem to be like, hey, guess what? 3 squared plus 4 squared equals 5 squared. The Pythagorean theorem shows, hey, the radius or the distance from the center to every point on the circle is always 5. Radius is the distance from the center to the edge. The diameter is the distance through the center across a circle from one side to the other. A chord as well. Circumference is pi d or 2 pi r. And you label that in units or inches or feet. And then area is equal to pi times radius squared. So you take the radius squared and times it by pi. And area is always labeled in units squared or inches squared or feet squared, etc. And so remember, we know about pi. Well, when we're finding these answers today, we're going to be working in terms of pi for exact solutions and then decimal versions for the imprecise or the approximate solution. So we're going to give 2 answers for each. Using the circumference of the circle, we do pi d. If the radius is 5, the diameter will be 10. So pi d would be 10 pi. And we're going to label that in terms of centimeters. If you do 10 times pi, you got 31.5. No, 31.4. I'm not sure where we got that 5 from. And that's in centimeters. And then the area, you would do radius squared, which is 25, and times it by the pi, and you would label it centimeters squared. If you use your calculator to evaluate that, you would do 25 and then times the pi key, and you would get 78.3. And that's centimeters squared. If you do the second example, the circumference would be pi d, which would be 12 pi, and you'd label that feet. Use your calculator. 12 pi will give you 37.7 approximately, and that would be feet. To do this area, it'd be 36 pi. How come? You take as b feet squared. You're going to do the radius squared and times it by pi. If you do your calculator to get the approximate value, you would get 113.1. And that would be feet squared. Always, 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 your area is going to be in a unit squared. Circumference or length around a circle would be in terms of a measurement like feet or inches. Today, we're going to be reviewing partial circumference, which is going to be arc length, where we say, hey, what is the length of this arc in terms of inches or feet or something? And then we're going to also do partial area, where we find the area of a sector or a piece of a circle. So to do arc length, we're going to use the formula that we used before. It's going to be the partial over the total. So if you want to find this partial circumference or this partial length around a circle, you do, well, what degree, what part of the circle are you going to use? And this length is x. The arc length is x over the total circumference. So that you use the total circumference here. And you can use pi d or 2 pi r. If the diameter is 20, it'd be 20 pi. And so it's going to be partial over total equals partial circumference over the total circumference. It's shown in this box up here. To multiply this, you cross multiply. You multiply 60 times 20 pi. You multiply the numbers. You get 1200 pi. Just leave the pi as a pi. And then equals 360x. And then you're going to divide both sides by 360. The most precise way to do it is to reduce the fractional coefficient of pi. So you can use the fraction key in your calculator. You can write 1200 over 360 and reduce it. And I get 10/3. And you label that in terms of inches. And then to get the exact answer, I mean, you could divide 1200 divided by 360, you're going to get 10.3 repeating. So I will accept 3.3 pi. Okay, 3.3 pi inches. Okay. To get the exact answer or the approximate answer, you times that value by pi using the pi key. And the approximate answer would be 10.47, and that would be inches. Okay, around the circle, so around that partial circle. So to find the bottom answer, okay, again, to find this, we're going to do, that's 134 degrees out of the whole circle, which is 360. You do the partial length, which is x, out of the total distance around the circle. And that's going to be circumference, which is pi d. So that would be, if that's 8, it would be 16 pi. Cross multiply 134 times 16 pi, or just multiply the numbers and then put a pi after it. So it'd be 2,144 pi equals 360x. Cross multiply the other way. Divide both sides by 360. So I'm going to just divide by 360, and I get 5.95555. So 5.96 pi, and that's going to be in centimeters. And then to approximate, you times that by the pi key. So you just take 5.96 times pi, and you get 18.71. And that's going to be centimeters. So given in terms of pi, it's best if you can do a fractional coefficient of pi, but a decimal will be true as well. And then the approximate answer is you just times that fraction times pi, and you get the decimal approximate of it. On the back, the main thing we're going to focus on would be, can you come up with the partial out of the total? So if you're trying to find out, what is this area of this partial part of the circle, we're going to say, okay, well, let's make it to be how many degrees it is out of the total, okay, equals the partial area. We're going to call this x, okay, x is this, over the total area. Total area. Okay, so the total area is pi r squared of the whole circle. So partial degree out of the total equals the partial area out of the total area. So you do the radius squared times pi. So the radius is 12, so it'd be 144 pi. We're going to need a calc. So if you cross multiply, you're going to take 131 times 144 pi. I'm just going to multiply times 144 and carry the pi along. So you get a very large number. It's 18864 pi equals 360x. I'm going to divide both sides by 360. So if I take 18864, just the numbers, and divide by 360, I'm going to get 52.4 pi, and that's going to be in meters squared. And if I take 52.4 times the pi key, the area is actually going to be 164.62, and that's going to be meters squared. So I want you to do one where it's kind of a coefficient of pi, meters squared, and one that's going to be the decimal approximate of that answer. Now, the last question that we did in class was talked about pizza, and I think this is a good question to kind of practice bringing things together. It says, what is going to be the area of one piece of pizza, and what is the arc length of one piece of pizza? You're like, what? Well, you can figure out if it has 8 pieces, you can do 1/8, divide 8 into 360, figure out how many degrees it is out of 360. Another option is, if we're just talking about the part out of the whole, it's one piece out of the total 8. You can talk about how many degrees is out of 360, or if you have a true fraction, it's going to be 1 out of 8. And so it's part out of total. And then if you're trying to find the area of a piece of pizza, okay, how many square inches it's going to be, you call this x, and so that area is x out of the total area, which is going to be 36 pi, the radius squared times pi. So the diameter is 12, so the radius would be 6. You cross multiply, We get 36 pi equals 8x. Divide both sides by 8. And I'm just going to get a decimal, an approximate answer. So I'm going to take 36 times pi. And I'm going to divide it by 8. And I get 14.1. So it's 14.1 approximately inches squared for a piece of pizza. Okay, so that means if your bites are just an inch by an inch, you could maybe have 14 bites in this piece of pizza, okay? And then the next thing they ask you to find is going to be the arc length of a piece of pizza. So that would be the length of the crust, okay, of one piece of pizza. So you do what fraction is that of the whole circle, okay? 1/8 of the whole pizza, part of the total. And this time x is the arc length, so that's x, out of the circumference, which is 12 pi, diameter times radius, or times pi, and then cross multiply. So you get 12 pi equals 8x. Divide both sides by 8. I'm going to just do 12 times pi in my calc equals divide by 8 equals 4.71. That means that a length of a piece of crust, okay, one piece of pizza, the crust is 4.71 inches big. So you can kind of imagine what it is. So I asked the question below here, what does arc length mean? Well, that's the length of the crust, okay? They're yelling next door to me. And what about the area? Well, that's how many bites there would be. Okay, if it's an inch square, every bite would be. Now, is your bite exactly an inch square? Probably not. Okay, but we're looking to say, what do we have? Okay, so the last couple questions, we're talking about, can you find the radius and diameter or circumference from the given information? We've done this before, so we didn't get to it in class, but I'll work this out in case you have questions to say, okay, if area equals pi r squared, okay, and you have the area to be 144 pi, well, then we can solve this to figure out what it is. Divide both sides by pi. And then to get plain old radius squared, you're just going to square root both sides. So the radius is equal to 12. And so 12 what? Centimeters. Okay, it looks like. And so the diameter would be 24 centimeters. And if you had to find the circumference, you could use the radius or diameter to find the circumference. So I think they're going to ask you to do that on some of your questions on your Delta Math. Again, if they give you the area equals pi r squared. Cool. So this area here is a 25x squared pi, okay? And that equals pi r squared. Divide both sides by pi. So you get r squared equals that. So square root both sides. So if you square root this side here, the square root of 25 is 5, the square root of x squared is x. So I guess your answer is 5x for the radius. And then that means that the diameter would be 10x. Okay, cute. Excuse me. Let's peek at the bottom question. We've done that yesterday. If you have a trapezoid with an area of 124, it's a formula. If they give you the height is 3, one of the bases is 12, can you find the other base? So let's solve this. So you get 124 equals one of the bases, doesn't matter which one, it's going to be 12 plus x, and then times 3 over 2. Multiply both sides by 2, you get 248. And that equals 36 plus 3x. Okay, just try this. And then you minus 36 from both sides. I'm going to use my calc. So if you do 248 minus 36, you're going to get 212. Divide both sides by 3. You get 70.7. And that would be meters. So to be fair, if you know the equation and you know 3 of the 4, all but one of the variables, you can solve for the variable you don't have. Okay, and so learning to work algebraically with formulas is going to be an important part of today. Thanks so much. Bye.